One.
Welcome aboard, folks. Appreciate you coming in today. If you're here for a talk on technical debt, you're in the right place. It's going to be a little bit odd for me today because I'm used to doing these in person, and so there's going to be a little bit less feedback and responsiveness, but I will say in advance that you are welcome to jump in at any point during this presentation, bring in your comments, questions, etc. Justin will be feeding those to me, and we'll be responding to those as we go. These presentations work a lot better if you're engaged and involved. And what that means is that you are very welcome to shout at the screen, throw popcorn at the screen, heckle me as I do presentation, because I'd much rather that you be interested and involved with the presentation than sitting and listen patiently as I talk about something that you're not really that interested in. So feel free to participate to the extent that this venue lets you do that. Fair enough? All right, welcome aboard, folks, thanks. So I like to always start with a little bit of motivation for my talks, and I want to talk about why you should care. So I know a lot of the folks who are tuning in are either going to be software developers or project managers, and most of you who have worked on a project in the past where things just built up over time such that the project falls apart under the weight of all the cruft that has accumulated from shortcuts we've taken or bad decisions that we've made, places where we've done less than the full job or less than the perfect job. You know, we have had many times in the software industry where we actually built the product, but we couldn't deliver it. We couldn't wrap it up, put a bow on it, and convince people to actually use it because we built something that was so over-engineered, so baroque and complex that our end users couldn't actually make it function. Or where we have failed to anticipate the end product enough that our beginning efforts really contributed towards that end goal. Or we built something and it turns out that that wasn't actually what the customer needed, right? We built what we were told they needed, but we didn't build what the final result needed to be, and so nobody wanted to use it, right? Those things that we thought of as edge cases or as things we'd get back to later turned out to be deal breakers for our customers. Now, I'm a big fan of the idea of trade-offs. I'm a big fan of the idea that the only really interesting problems are the ones that are not an obvious answer, right? If you can snap to an obvious answer, it's not an interesting problem. In this case, we wind up in the situation where we want to actually deliver results. One of the core concepts of agile software development is get the product out there, let it be tested by the market. Don't try to engineer everything up front. Don't aim for perfection, aim for testable. But on the other hand, there's the old maxim in software development of garbage in, garbage out, where if we build something that's cobbled together and barely hangs together, the next thing we built is going to have to take into account all of those complexities and half-built pieces, and as a result, we're never going to get to a quality product. So how do we strike that balance between the perfect that we never actually ship and the half-assed that we cobbled together and never actually deliver? So I'm going to pause for just a moment and let you folks put in any of your stories that you have of where have you seen these kind of ugly deliveries. I'll pause for about 20 seconds and then I'm going to move on with the rest of this conversation. All right. Hopefully that will get some conversation going. I don't want to wait for too long for those responses to come in because I'll lose people's attention as they wander off to go to the bathroom or fetch a cup of coffee. So this is the moment where I'm hoping to get some conversation going. Feel free to keep contributing those in the chat. In the meantime, though, I should probably introduce myself. So my name is Eric Huckabay. I'm one of the directors at Improving, and I've had kind of a complicated relationship to debt. When it comes to code debt, I have been a serial code debtor. Once upon a time, I would have liked to have described myself as pragmatic in that regard, right? Get something that works, get it out the door, but let's not linger on kind of the boxes and arrows and finding the perfect design. I tend to approach things from the perspective of making things as easy to change as possible. And one of the jokes that I like to tell about architecture is the definition of architecture is the things that are hard to change in a software project. And the definition of an architect is the person whose job it is to make sure there's as little architecture as possible. I am an investor, and interestingly enough, I'm a saver in my personal life. I'm not somebody who runs around with a lot of credit card debt because I've seen some of the damage that that can do to people. But I've also worked in a hedge fund where a significant part of the role was understanding what is a good investment, what is good debt, what is bad debt, what is the performance characteristics that let us leverage people's money and see a return on that without trying to find the absolute perfect answer, the absolute all-weather stock, etc. In fact, when I worked with the hedge fund, my job was building the marketing application for the hedge fund that they used to explain why you should pick their investments. And so I was exposed to a lot of the reasoning behind investing in certain ways, using money in certain ways, and using debt and leverage, and how those things correlate to each other, how they interact with each other. Finally, for my family background, my mom is super thrifty. There's a joke in my family that my grandmother actually saves all the receipts that she gets from the store so that she has scrap paper to write on. My dad, on the other hand, was a spender. He would go out and go to restaurants for most meals, impulse buy things. He was a big fan of things like Overstock.com and that sort of thing. And so I kind of got both perspectives from the, you have to make sure that you have a safety net, and that safety net has to be 2 miles deep because you never know what could go wrong. And on the other hand, we have the, let's just work with what we've got now and have confidence that we'll be able to recover and fix the things that are wrong when they go wrong. All of that informs my relationship to technical debt as well. So what I'm going to be talking about in this presentation is, what are we talking about when we talk about technical debt? And then we're going to talk about the concept of good debt and when it's a good thing to have technical debt as opposed to bad debt, and when it's a bad thing to have technical debt and something we should do something about. We'll talk about the negative consequences of debt being a drag on your overall performance and your ability to build the system that you're trying to build. But we'll also talk about the ways that you can harm yourself in the process of trying to fix all the problems and make the perfect system. And then what we'll do is we'll talk about the balance between deciding that we're going to keep debt or deciding to incur debt in the first place and fixing that debt, revisiting those decisions that we've made in the past, and try to figure out when it's a good time to make those decisions and those investments. And then finally, I'm going to give you some resources that you can use for referencing some of the big thinkers in our industry on the topic of technical debt, and a little bit more elaboration on the topics that I'm going to talk to you about today. So that was a bunch of introduction. Let's move into the actual content. So when we build something technical that works, but it's not the best way we could have built it, and we promise ourselves we're going to go back and fix it later, that promise is technical debt. Now, I suspect that there's a few people listening to this who have written code that was not perfect, or that was not the best code that they could have written at the time. Maybe that was because of deadlines. Maybe that was because of lack of knowledge about what the whole system would do. One of the sneaky things that can happen to us, though, is that we can actually incur technical debt retroactively. One of these days, I'm going to take all the things that I've learned since we wrote that module, or all of the employees, all of the new technologies that have come out since we wrote that module, and go apply them, because it could be so much better than what we built the first time around, right? The industry continually invents better ways to do things. Our industry, as a business, continues to invent better ways to improve their business processes. And if they don't, we have problems with stagnation. So there will never be anything that you wrote that you won't want to go back to and fix it and make it better, because hopefully you're getting smarter all the time. My coworker Devlin likes to tell a story of his humility folder, where a few years after he writes something that he's really proud of, he goes back. When he writes it and he's really proud of it, he drops it in a folder. He goes back a few years later and reviews that code that he wrote that he was super proud of, as a way of reminding himself that the code that you think is awesome today, in 2 or 3 years' time, you're going to cringe at and wish you could go back and write it better. That's technical debt, and you will never stop accumulating technical debt. The reason for that is that there are constraints in the business world that govern the fact that we actually want to ship software. The fact that we're not writing software for the purpose of building perfect software, right? We're not building it as an example for everybody to use. And if we were, we'd have to write a whole bunch of different examples, because everybody's at a different level in their learning process. So technical debt is something that we will continue to incur, something that we will even sometimes intentionally incur and not just retroactively incur. So let's talk a little bit about debt as a concept. If you have a student loan or something like that, when should you pay off your loans early? Let me give an example. Suppose for the moment that the federal government sets a limit on how much interest your student loans can charge you. And that limit is something like 3%. Say, for example, that the stock market has been doing very well and you expect it to continue doing very well. Say you have some sort of guaranteed return investment, like a CD or something like that. If it's paying a higher rate than the rate of that money that you would be paying back, should you avoid paying off the debt? Because the money that you have now could be appreciating at, say, 5%, whereas keeping that money in your hand is costing you 3%. If you give it back, you remove that 3% appreciation of the debt, but you don't get that additional 2% that you could have gotten by investing it. So be aware that loans can be good. We take out loans for a reason, and paying them back isn't always the best decision. Now, the other thing is the time value of money. So one of the cool things about having money in savings, about having a good income that's steady and reliable, about having safety nets, is that they let you make decisions about when to spend that money, right? I get the option to go to Costco and buy the 20-pack rather than the 4-pack. And the 20-pack costs less per item. As long as that investment is not going to go bad, as long as I'm going to be able to use it, it's better to make that as an upfront choice, spend all that money at once, unless there is something that I should have spent it on instead. That's the opportunity cost of spending that money, right? But having that flexibility, having some margin, gives us the ability to make those decisions about when to do things. And so if we are overburdened with debt to the point that we can't afford to take out any more debt, we lose that ability. We're forced to fix it now. When the system that we've built is so unsustainable that we've got to spend all our time fixing crises, that doesn't give us choices about the cool new feature that our competitors just introduced and trying to match or better it. It doesn't give us time to do market analysis and figure out when the opportune time to release a new feature is. If there is an industry convention or presentation that might be a good time to introduce it. So we have to be careful about managing our debt in an interesting way and in a useful way. Now, there's also a problem with debt in that there are self-fulfilling prophecies when it comes to debt. There's an emotional cost to debt. If the software that you are working with feels like a piece of junk, you are emotionally less invested in it. And you are going to build less high quality software, because why make a beautiful piece of software that's just going to have to plug into a piece of garbage? So there's a headspace that you have to get into when you're building the software around what is the emotional cost of debt and not just the maintenance cost of that technical debt, right? From a monetary perspective, if you are so deep in debt that it's keeping you up at night, or that it is affecting your work performance, you might need to get out of that debt, even if it is not the most sound financial decision for somebody who has a completely logical perspective. Because as it turns out, none of us as software developers, as individuals who manage money, is completely logical and rational about all of our decisions. If we were, we wouldn't have things like fluctuations in the stock market. We wouldn't have things like people who go to payday lenders, etc. Right? We've got to account for the fact that our systems, either our systems of debt and money, or our systems that we're designing technically, have to be both used and maintained by people. And so there are important factors that go into that. There are factors like how comfortable is your boss with the software that's been built? Because if you're saving room for some big feature that you're going to deliver down the line, but they decide to cut the project, you're never going to get to that big feature. All right? If your cash flow puts your company out of business, it doesn't matter how cool your product was. The other thing is that debt can interact with itself in interesting ways, especially in a technical system. So the theory of constraints is a system of deciding what to work on first that I'm very fond of. And basically what it says is find the place with the largest bottleneck and focus your effort there, which is great as long as the place with the biggest bottleneck is singular. But if there is more than one problem in a system, that is constraining things to the same rate of flow, fixing one of those problems won't suffice to increase the overall flow. You can have situations where you cannot design a well-built system over here because of the fact that it's got to integrate with a poorly built system over there. So you may have to repair some of that system, change some of the functionality that you've already built and that's already working. Well, that's the definition of technical debt. Going back and fixing things that already work to make it work better so that you can improve performance in the whole system overall. So let's talk about the problem of debt. Debt is a drag. When you have technical debt, it slows everything down because you are constantly paying the interest on that debt. It creates inefficiency in your system. It creates a system where you can't be confident in the way the system works because it's not built optimally. It doesn't match your mental model of how it should work. What that means is that in order to design one small piece of software, you have to be able to mentally model the whole system and all of the ways that it's potentially broken that could interact with the piece that you're working on. The reason we try to create separation of concerns is to reduce that cognitive burden. That how much do I have to relearn every time I come into this system? Cleanly and efficiently written code is something that you can understand quickly, and as a result, modify quickly, modify with confidence. And so every time you have to touch that code that was written inefficiently or in a way that's hard to understand, you pay extra hours in trying to relearn the code, understand what it's happening, understand what the side effects might be, so that you can effectively change that code and add the features that you need to. The other thing is that bad code accumulates, right? We just talked about the fact that there is a cognitive burden, that there is a sense that if this code is bad anyway, why should I bother to make good code? And so there's the hazard that you or the people around you, when they see code that is half thought through, are just going to slap something together, make it work in the most minimal way possible, do red, green, and never refactor, and thus it becomes that much harder to understand. And it continues to become harder and harder to understand until you decide to go do something about it. But even then, there is a sense that if you have good code sitting next to bad code, the standard that people will tend to follow is the most relaxed standard, especially when they're dealing with things like time constraints, when they're dealing with the trade-offs that come with a realistic business scenario. Because nobody's sitting around coding because they feel like it. Nobody's sitting around, with plenty of time on their hands to get all of their projects done. The other thing that debt can create is knock-on effects, where something behaving in a way that you didn't expect in a module that's significantly downstream of what you're building creates unexpected results in your system that can lead to bugs, that can lead to debt. So there are some motivations for trying to tackle debt, trying to speed yourself up, because if you're moving faster, you may get there sooner than the person who's moving slow but constantly moving forward. The solution to technical debt, whenever possible, is to simplify. There's the old saying that is, I believe, misattributed to Albert Einstein about make things as simple as possible, but no simpler. If you don't need something, don't introduce it, because then you have to understand it. You have to understand how it's going to interact. If you can avoid making a decision, make it later, make it at the last responsible moment so that you have as much information as possible and you don't create more debt by building something that you don't yet fully understand. When you duplicate code, you're creating a situation where a fix can potentially go in one place but not the other, and now you have mismatched code for mismatched processes. In general, technical debt is only worth removing if it removes a burden from you, either a burden of understanding or a burden of how hard the code is to work with, or a burden of that emotional dislike that prevents you from working effectively in your environment or with your code. If it's not that bad, or it's not that regular, apply that Yagni, you ain't gonna need it rule. Deal with the fact that your code's imperfect. Grit your teeth and move on, right? It is okay for there to be terribly written code in your application if it works and nobody ever has to look at it. When you revisit the code, when you are having to learn it the first time, that is always the time to think about, now that I've spent the effort to understand is there something that I could simplify about it so that the next person to have to understand it gets that opportunity and doesn't have to spend the effort that I just spent to relearn and understand what we built the first time around. Okay? But then there's a decision that has to be made, and we'll get to that decision a little bit later of, then is it worth the effort of that simplification? Understanding what the code is doing is always the first step. Trying to get into the headspace of the person who wrote that code, rather than just roll your eyes and say, oh my God, this was written by an idiot, is always the first step. What was made easier by doing it this way? I can tell you that I have written applications for 3 different customers at least 3 different times, and the third application was significantly better than the first one because of the lessons that I had learned. But I couldn't have just written that third application. I have made lots of bad decisions in my career because I was under time pressure, or the alternative was worse. So try to put yourself in the shoes of what happened that created the code the way it is. Because many times you will find that you were that idiot that wrote the code badly. Try to simplify, try to make things more understandable and easier to work with. Now, the other end of the problem. Have you ever tried to, oh, I can go make this a lot simpler, and you simplified it, and then you forgot about all those edge cases, and suddenly there are bugs in your code, right? Oh, I can't believe this idiot did this the way they did it. I'll just go replace it without fully understanding, because nobody's software is fully documented unless they are pure TDD shop where every line of code is covered, right? You have to understand all of the potential effects, or else you will break things. And that is dangerous. So understand that there's a risk involved in paying down that debt. The other thing is, as I've gotten older and smarter, I have learned how to do some pretty cool things. Some of those cool things make things simpler, but some of them don't. And one of the challenges that we can introduce for our coworkers is building a solution that only we understand how to use. If you replace a working system with something like the visitor pattern, you'd better make sure that not only do you understand the visitor pattern, but everybody in your environment understands the visitor pattern, and everybody that you are likely to hire in the future has a way to get onboarded into the visitor pattern. Unless you are confident that no one will have to look at that code again. And that's really hard to be confident in, given that you are not yet aware of all the requirements that could be added to your software. A bad but well understood solution that is the same as the solution that was applied everywhere else in your system can be better than something that where you have 7 different solutions and nobody's quite sure which one we're using in any given situation. Think about what the cognitive burden is of having all 7 of those different solutions in mind, choosing between them, deciding when to switch between them, right? I have met many young developers who have come in with a really good idea, and it was genuinely a good idea. But because we weren't willing to make the investment to apply that good idea throughout the whole system, it created a hard to understand system because it created that setup where we had this half-done initiative here and half-done initiative over there. And that is technical debt. Despite the fact that they may have improved things in a local area, they may have created more overall debt in the system as a whole. But here's the worst part about fixing technical debt. It takes time. You could be doing something else. You could be creating features that make money. So, if you are going to pay down that technical debt, it had better be worth it. We'll talk about more about that shortly. So, whenever possible, you want to avoid an oops. You want to approach fixing technical debt with humility. You want to make sure that as much as possible, you have put a box around what it is that you're going to be changing, and it's not going to impact other areas of the application. Yes, unit tests are incredibly helpful here. Any kind of tests, for that matter, are incredibly helpful here. And if they don't exist, the first place that you should be paying down that technical debt is by ensuring that the code can be changed without breaking, without creating more problems and more debts. It is very rare that you will add tests and that will increase your debt. Now, are the tests worth it is another conversation. It's the next conversation we're going to have. Another point that is very important to keep in mind is that restructuring and refactoring are not the same thing. If you are changing the behavior of the code, that is not refactoring. Keep those two behaviors separate. A change should either change what is happening or should keep everything constant. But between the two, if you want to restructure your code, make sure you have a way to go back. Apply feature toggles, apply branching, apply a strategy pattern. Any of those are good solutions for ways to make sure that you can completely isolate the things that you're changing and keep the old behavior in case you need to roll back to it.
I got a question kind of about that, Eric.
Sure.
It says, do you feel that a clean version history can help you understand why decisions were made? And is this a use case for things like combining or squashing commits to usable chunks?
Absolutely. So a clean version history can help you decide, help you understand why decisions were made if the problem is clutter. If the person didn't explain why they were doing things, if they only focused on how they were implementing things instead of why they were implementing them, even a clean version history won't help you. But if the version history is so cluttered that it's impossible to associate those reasons with the lines of code that you're seeing, that similarly becomes useless documentation. So I absolutely do think that a clean version history is one way of keeping that humility in mind of somebody else is going to have to look at this later, make sure that they understand what was done in a way that they can quickly and easily understand, right? It's still in that same concept of cognitive burden. Let me know if I answered your question. In the meantime, I want to talk a little bit about investment. So, what proportion of professional money managers manage to beat the market, do better than the average of the market? The proportion is just over 50%, just barely. And that's because of the definition of average, right? Most of the people in the market are professional money managers. Now, if you had to pick which of those professional money managers to invest your money with, how do you know if they're going to beat the market? Because we've all heard the past performance doesn't predict future results, right? And it's not always the same people who beat the market. In fact, there's a lot of volatility and noise and randomness there. So in order to beat the market, you have to have some sort of inside information. You have to know more about the market than is average, or you have to have experts who know more about the market than is average. Humility is important when you're addressing technical debt, because you need to ask yourself that same question. How much do you really know about the overall system, how it's interacting, and make sure that you are not trying to create that local fix that makes the broader environment harder to work with. You want to make sure that you're not churning and trying to make bets without having the big picture, without having a holistic understanding. This goes back to what I talked about before with debt, as far as listening first, understanding the full system, trying to separate concerns so that you can get your head around it and really understand what it is that you're changing. Whenever possible, make small changes, not sweeping changes. Move things forward in baby steps, but continue those baby steps until things become consistent. How many times have you checked out code thinking you were going to make one little change, and while you were there, you decided to rename a variable, and while you were there, you decided to clean up some code, and then you realize, oh, I didn't merge those, so now I've got all three of those in my pull request or my commit history mashed together. And now I've changed file names. So if somebody else has worked on this file, how do I tell what their changes are versus the file delete and rename? How do I tell what the small increments of that were if I need to disentangle them? The smaller the steps, the easier it is to roll back. The smaller the steps, the easier it is to understand the effects of what you've done. One of the core skills that we all know we have as developers is breaking down big problems into small incremental steps. And yet, how often do we think that we're smarter than we are and just try to, oh, I'm just going to real quick fix this while I'm working on this other thing? Not me. I never do that. Humility is one of the keys to being a good developer. So, how do we evaluate what tech debt we pay? So here's some of the problems when it comes to evaluating those decisions. If your business trusts you and you go to them and say, hey, I need to change the version of package X. It's going to take a week. How often is the business going to argue with you and say, no, package X is just fine where it is? How often are they going to say, oh, okay, that sounds technical. I guess if you say we need it, then we need to do it. But I was really hoping that we could do this other thing. So can you try to make sure it goes as quick as possible? Because the problem is, if you get that answer of, you're the technical expert, you tell me what we need, you say we need to pay down this tech debt because it's just impossible to work with, you'll probably get that answer more than a few times. But over the long run, you're making a wager against the trust that they have in you. Because at some point people start saying, and many of us have been in environments where they've built up this attitude, where the default is not tell me what we need, where the default is no. It's working, stop touching it. I am not paying anything down. I want new development. Remember that when you are evaluating the return on an investment, there is not only the quantity of return that you are expecting to see, there is also the frequency of that return, or the time frame of that return. If you rewrite a module and it takes you 2 days, say 16 man-hours to rewrite that module, but every time you have to touch that module, it saves you an hour understanding what that module does. Should you rewrite that module? How often are you touching that module? Are you touching it more than 16 times in the lifetime of this application? If it's a core module that's the business that you do every day and that is constantly being expanded and modified, it's probably worth it. If it's something that you touch 2, maybe 3 times a year, that hour of saving doesn't get amortized very quickly. The other problem that we tend to have as developers is one that I'm going to call foreshortening. If you look at the picture that's up at the right-hand corner, is that a picture of a car? Because I'll tell you, it's not. If you look at the far right-hand side of that picture, you'll see the size of somebody's head. Because those are, in fact, model cars. They're very detailed, but because they're close to us, because they're close to the camera, they look bigger. And we techies have a tendency to overvalue our own pain, especially in businesses where they don't give us exposure to the end users. So we don't hear their complaints firsthand, and we certainly don't experience them firsthand. So we tend to overvalue our own pain because we know what a pain in the rear it is to work with that ancient module or that horribly written piece of code. And we can advocate for ourselves very effectively to the product owners because they can't contradict us on this is important for technical reasons. So be careful about overvaluing your own pain. Be careful about undervaluing the pain that's far away from you, but that drives the business, that drives the money coming in that pays for this product. We get even worse situations when we're working for an IT organization and they have their own set of drivers and goals and things that are going to deliver from that IT organization that are different from the business's drives and goals and things that make money for them. We have competing concerns there, but the IT organization is a lot closer to us, so their values and their goals tend to be better represented. Finally, there is an investment window. There is a good time to make investments. Strike while the iron is hot. Wait till the stock falls to the lowest it's going to for the foreseeable future, and then buy in, right? Buy low, sell high. Well, if you're touching something anyway, that's a great time to make changes to it, because you're already having to make that investment of understanding what's going on in order to make your change. So see if you can tack on as a separate task, but at the same time window, any tech debt that needs to be paid on that particular module, that's worth it. That where you're going to get back the value in a short period of time. You've got to figure out return on investment. You want to beat inflation. It's working now. How long does it take before somebody comes out with a feature that beats the one in your product? Would it be better to invest that money now in getting something to market or in testing an experiment? Because that tech debt will still be there, but it is also causing you continuous cost every time you have to touch it. What happens if things go badly? We've talked a little bit about the time to return on your investment, but what if your fix goes badly? Is it something you can abort? Is now the time to rewrite a system? If you're right in front of a funding gate, I would bet the answer is no. Right? If you're right in front of a major industry convention, is now the time to completely rewrite something? Probably not. It's often hard to roll back those big rewrites. All-weather assets are a concept in the investment industry that say the optimal investment is something that will continue to grow and do well no matter what the market is doing. And it's very hard to find those kinds of investments. But if, when the market is good for your company and the market is bad for your company, this investment that you're making will continue to pay off, that's probably a better choice of investment because the downside risk is less. Creating efficiencies is often a case where there is a clear value to be had, even in bad economies, right? There's an old joke about in a bad economy, it's a bad time to be a product manager and a good time to be a software developer, because nobody's starting new projects, but they all want to go make the systems they have do more with less. Then you've got your estimates versus actuals. How often have you said, oh, I could rewrite that in a day, and it actually took 3 days, or I could rewrite that in a week and it actually took a month? Understanding the fact that you're human and fallible in making these estimates on how easy it is to pay this tech debt is incredibly valuable to you in building that trust with your organization for giving you the right to say, no, this will really pay itself off. Having evidence that you were right about the fact that something would pay itself off gives you more ability to be given that privilege again next time. So here's some resources, and I believe Justin is going to put these into the chat for you if you want to control click on them into a new tab, because you probably don't have enough tabs open right now. Martin Fowler and Steve McConnell are two of the leading lights in our industry, people who have good, deep thoughts on this topic, and you'll find some parallels between what I was just talking about and the way that they tend to approach technical debt and paying down technical debt. All right, so I'm going to give you a quick recap. We'll have a couple minutes for questions, and then I will have a final slide for sort of a call to action. So here's your recap. Please feel free to go ahead and start submitting your questions because there's a few second delay on getting those to me. So I will address those after I hit the recap. It is okay to have some debt. In fact, you will always have some debt. you will never get to a pristine software solution. Paying down that debt can cost you. It can cost you in terms of bugs, but it can also cost you in terms of the opportunity costs. Thus, it's something that you want to be very deliberate about. It's something that you want to think through what the return is going to be for cleaning up that ugly code, and not just the return to you. What is the return going to be for the business? Because it's so easy to estimate only based on the pain that we feel in our lives as developers and not have a realistic view of how much that time saving is going to mean to the business, when we could instead be investing it in building them features, building them a system that does more. Whenever possible, make it explicit. Use real numbers, real measurements. When you're talking about how much it's going to take to pay off that tech debt and to fix things, but also about what the benefits are going to be. Make predictions. Even if you don't publicize those to the people who can fire you, making predictions and comparing them to reality gives you the ability to make better predictions. And when they do align with reality and with your predictions, and you do see benefits over the long term, you can show that as a way of building trust. So I'm going to pause here and give folks a chance to get their questions in.
We've got a few questions already. I have one kind of more specific question. It says, what is the best place to start when paying down technical debt? We have such a long-standing code, monolithic systems, and now are merging with another large firm. Should we start testing, refactoring? Should we just dump everything out of the closet and see what the biggest piece is? What do you recommend?
Okay, so my recommendation is a process that I call seaming, and I'm pretty sure that's not an industry-specific term. So you learned it here. And that is, if you think of a quilt, finding the places where the stitches are, where the lines of communication are fewest, the places that interact the least within that monolith, and start trying to chop that out along the boundaries. So the first step in chopping that out along the boundaries is understanding it, figuring out where those boundaries are, and trying to find the smallest pieces that you can to separate into small removable chunks, right? Some people will call those microservices, but I think that's getting ahead of ourselves a little bit. So a small module that you can separate and reduce the amount of communication it has to the outside world to a small number of connections. Then go in and add those tests, add that security, make sure that you really are understanding it, right? Building those tests around that small piece can give you the security that you have in fact understood it, creates the documentation that you can show to your bosses and say, hey, this is the extent of this system and how it works. And thus, when you're trying to merge two systems or what have you, serves as a form of documentation. Then create what I would describe as a strategy object, where you create a containing class that is roughly a static class that has all of those code segments related to that one piece or behavior. Okay? It's essentially a wrapper for that code that says, for this segment of the system, here's a description and all of the pieces of code that interact with that system. What that means is that you can potentially replace that class. So now take it from being static to being an instance, go to all of the places where that code is used and inject, or, if you must, create an instance of that strategy class that you've now created that is the old behavior, right? Everything is still working, everything is still running, but you now have one object that is replaceable. And you can swap in that object for the old behavior with something cleaner. with something that has a cleaner underlying implementation, but still maintains all the same interface and API? That's a pretty deep question, so I apologize that I can't go into it deeper than that right now. I actually did consider for today doing a presentation on exactly that question and exactly the pattern that I'm talking about. So if you're interested in that, let us know, and I can potentially give that presentation as well.
All right. Next question. I think you might have hit on it a little bit, but it asks, how can you prioritize paying down tech debt against other business objectives and deliverables that the business wants you to do?
So I'm going to be honest and say that I don't think that that should be my job, although it often is. So I'm going to describe the ideal situation and the less ideal situation. The ideal situation is find a way to describe the benefit, to predict the benefit of paying down that tech debt to the product owner in a way that they can make a prioritization decision based on the business. So if you can say, it will take us 1 less hour of support time every sprint, or 1 less hour of support time every time we have to interact with this module, that is a quantity that the product owner can work with and say, yeah, I could see using that extra hour on building new features from now on. That needs to pay itself off over this amount of time, right? That's the ideal situation where you can actually create a measurable thing that the product owner can understand as the benefit. Now, sometimes those benefits are fuzzier. So there are things like, well, there's a risk associated with not upgrading to this version. It's going to go out of support, and we haven't had any tickets in the last year or two, but if it's out of support and something goes wrong, then we might have to, enter a crisis mode and fix things on the fly rather than fix it as, with some safety net, etc. In those cases, it is a risk versus value conversation, just like any investment, right? And so what I would recommend there is be very explicit about the risks that you're trying to avoid in paying down that debt and the pain that you're trying to remove in paying down that debt, and then go to somebody who has an outside perspective and can give you a, how does this compare to what is the value of the thing we would have done instead, right? Try to quantify it as much as you can in terms of a trade-off. Usually we have, in an agile world, we have a backlog and a kind of a cutoff of what we think based on our current velocity is going to be in the release. If I say, hey, this is going to take me an additional 3 story points to pay down this debt, what's the 3 points of stories that are probably not going to make it into the release? Next question.
All right, last one before we have to wrap up. Do you have a list of recommendations for good coding practices so that we can avoid technical debt?
Absolutely, and that would be a really long answer, so I will just hit you with the solid principles and the grasp patterns, GRASP, are very good places to start on those code practices. And obviously, as I've mentioned several times now, unit testing and other forms of testing are a godsend when you're trying to make sure that you're not introducing problems by fixing that debt. Thank you, folks. Here's my call to action in the last 30 seconds. Start tracking the cost and the return of the technical debt that you're already paying down, right? Make a prediction and measure against it, even just for yourself, so that you can come back to the business and say, see, look, I told you this would be worthwhile. And if it's not worthwhile, then just shut up and maybe don't do it again. Make sure you're being clear about your intent and your competency. You will be forgiven for mistakes if you are generally competent and if you have good intent. If you show people what the alternatives were and why you made the judgments and the decisions that you made. And above all, please remember, you are borrowing against the customer's money. Your time is something they are paying for, and therefore you have to make sure that they agree with your decision about the money that you're investing by taking some of their time and putting it into tech debt. Thank you, folks. I appreciate you taking the time to come and listen today. Happy to continue these conversations electronically if you'd like to. You can reach us at Improving, and I'm personally at eric.huckabay@improving.com. Thanks much.